Thanks, Dwayne. Hello, everybody. I'm Arlen Nipper. I am the CTO for Cirrus Link Solutions, and I've been doing industrial solutions for the last 46 years. So, what Cirrus Link do is that we basically develop all of the MQTT technology for the Ignition platform that you need to be able to create contextual hierarchical, UNS formatted data models and data infrastructure for a UNS solution.
Okay, great. James, how about you?
Hi, everybody. James Burnand. I'm the CEO of 4IR Solutions. 4IR Solutions, a lot like Cirrus Link, we work very closely in the inductive ecosystem. We are inductive automation's solution partner for managed infrastructure. What that means is we deliver Ignition and the databases and all of the componentry that you would need, including Arlen's modules as a service. That service is called Factory Stack, and it can be delivered in cloud in AWS or Azure, or it can be delivered on-prem with a variety of different technologies for edge and hyperconverged.
Okay. Now to my colleagues here at Flexware Innovation. Eric, how about you?
Hey everybody, my name is Eric Moorman. I am a Spark architect here at Flexware Innovation on the Ignition team. Here at Flexware, we are a solutions integrator, so we serve a lot of different roles with helping our customers to really figure out how to use all these different technologies and to define what could a UNS or other solutions like that really look like for them. So we play a lot of this role in upfront helping to design and also practically implementing it. And so we're looking to hope to use some of that experience to show you here today how you might get started on that.
And Nadir?
Hey, thanks, Dwayne.
You're muted.
Hello,
Right
everybody. Yep. Hello, everybody. My name is Nadir Khoja. I am the solutions architect at Flexware Innovation, and been in this, manufacturing industry 4.0 space for the past 10 years. Just helping customers understand the requirements that they have to make a UNS, and then also what technology they need along the way to get to a proper UNS-based architecture. And I've also been fortunate enough to teach machine learning and AI and all that to postgraduate students here locally. So I bring the data science and the manufacturing together. So yeah, happy to share my views on how we get a UNS in a proper way.
Awesome. And Jacob, we're going to finish off introductions with you, and then I think you're going to kick us off into the meat of the presentation.
Yeah, absolutely. My name is Jacob Clodfelter. I also work for Flexware Innovation. I've basically lived and breathed the digital transformation, IIoT community since I got out of college. Love this industry, huge supporter of the I4O community and all the power that UNS is bringing and helping manufacturers in the United States and at large in the world. So we'll be going into how to enable that and hopefully simplify it down. That's the large premise of this particular webinar, is making it simple for you guys. So yeah, we'll get right into it.
And Jacob, if I'm not mistaken, you are the presenter, so you should be able to share your screen.
Hey, real quick before we get into the demo and while Jacob's getting his screen shared, I think before we actually get into it and start actually showing an example, so we want to really show the practicality, like try to take an approach of not just talking theory. We want to talk some theory, right? But we also want to have, we have some of the industry leaders here, right, to talk about tips and tricks we have. How can you really go about practically building out these solutions and not being completely just theory based? So we're going to start out that by showing a demo of just like kind of a mock-up of how this could look, right? But before we even get into that, I think it's probably good for us to just level set, just spend a real short amount of time just talking about what is UNS. Like, let's just try to briefly design that concept for anybody who may be very new to it. So I don't know, Nadir, do you want to maybe take a first stab at that? Anybody else can build off of it if you want to?
Yeah, 100%. Thanks, Eric, for kicking that off. So a UNS, what I'll say is people think a UNS is where I can go get my data from, right? People in the industry are like, well, I think it's a database, or I think it's a collection of information that I'm gonna have to be able to interact with and pull it off. So there are some of the, like, I wouldn't say misconceptions, but that the ideology of a UNS versus what it actually is, that's the difference between the thinking out there. So if in theory is what we're not here to discuss, right? So a UNS to me is more or less a facilitator that has the definitions of what you are looking for in the context of your organization, but it actually is helping you to collect that information in the right way into your data lake. So, or a lake house, or a warehouse, or whatever you have in your organization. But a UNS to me, in a very simple sentence, is the facilitator of your information that enables you to do magic with the data that you're trying to do upstream. Anybody else has any thoughts towards that?
Yeah, and I we talk a lot about it, and ultimately it is a concept, right? And it's a combination of organization and hierarchy and an open transport mechanism. And I think it can be a little confusing for some folks to go, well, is MQTT a UNS? And it's a key component to a UNS, but it by itself is a pub sub
Yep.
technology. And certainly, when you layer over top data modeling abstractions and the ability to then make that data accessible and have a proper security model for exchanging it with other systems, that's where the UNS concept becomes reality. And I think it's important to try to make sure people understand it's not a box on a shelf.
Well, and the
Exactly.
reality is, in our world, we're still interfacing to PLCs, RTUs, flow computers, factory control equipment. And let's face it, we are still in a world where that data coming off of a PLC is nebulous garbledygook, right? And
Mm-hmm.
our job, first and foremost, is to take those registers, those values, and convert them into something that a human being can understand. So on the factory floor with the tools that we've got, being able to take, like, one of my favorite pet peeves is enumerations. If you look at a PLC, you may have hundreds of enumerations, an integer value that means something. 1, 2, 3, 4, right? And so when it
Yep.
gets to IT, when it gets to the enterprise, my gosh, look, you got an IT guy, it's got machine state 3. Well, is that better than the 2? Right? Or is it worse than the 2? So one of the things that we've got is tools like with Ignition using expression tags to take every um enumeration that we've got and literally blow it out. So my example that I've got is like in the oil and gas industry, we've got a flow computer, and a flow computer has a orifice plate, and the orifice plate has orifice material. And all flow computers enumerate that 1, 2, 3, 4, 5. But we can change that to stainless steel, Monel, carbon, stainless 104, so that when it gets to the enterprise, now they can look at that and go, oh, I know what the orifice material is for that particular flow computer. So I think that's the start of it. And then we organize that in a way, like Nadir was saying, that when it gets to your data lake, your Snowflake instance, whatever, now it's something that humans can understand.
Perfectly put together, Arlen. Thank you. Yeah, exactly. It is the facilitation of information that is relevant to your business when you need it upstream, right? So a UNS is basically that. Jacob, please go ahead and share so we can show the people what they're here for.
Yeah, absolutely. I think Arlen nailed it there too. We're trying to solve real problems. You need human readable information. We're trying to turn the data that's on the shop floor into actionable insights and results, and drive change for manufacturers on the shop floor, actually produce things. So there's a point to all of this, and it comes in the readability, understandability of the data. So yeah, so let me share. really quick here. Let me know if you guys get the share.
Yeah, we'll see
Yep.
ourselves. There we go.
Yep.
Yep. Here we go.
Yeah,
Yeah,
you should see the
yeah,
screen here. Okay.
yeah.
So here, I'm trying to tell a story a little bit, something that like a lot of C-suite people will be seeing. This might be what you think is UNS. This could very well be something that you get presented in a boardroom when you're trying to implement UNS. And I'm looking here, I'm like, oh my gosh, like this is UNS. There's so much going on here, and this is not even a comprehensive sort of slice across the entire space. I mean, this is maybe 70% of the technologies that are in play in these sorts of solutions. But you know, I think that a common misconception is, as we're moving from this, let's let's get straighter to a point here. Um, and of course, this is the architecture that we're going to show to you today, and it is a somewhat simplified architecture here. And of course, we're using the Cirrus Link stack on Ignition, and we're also hosting all of this on with 4IR Solutions in cloud and their factory stack solution. And in large part, we'll show you that the work that Arlen has done and James, and of course, SIs in collaboration, have really simplified this process to where you're unlocking massive power from a UNS in very early stages for a POC. So, and I kind of want to, even this seems somewhat obtuse, I think. This simple diagram is what you're going to see here. We're taking data from a machine, we're passing it through Ignition, and we're passing it into a central backplane of data, which we're going to show you where we're going to do with that data in just a second. That's definitely where we're going to start here and try to simplify UNS. So what we're going to show you really quick here, we're just going to go into a demo, and then Eric, once I demo a couple things, we can kind of revisit, ask questions, etc., and explore that. But um, I really want to showcase how easy it is with Arlen's Cirrus Link transmitter, distributor, and engine. They put a ton of work into making this practical and streamlined. It really low code, no code at this point. Um, so with a simple configuration, I'm not going to go super deep because they have really good documentation online, but what you're going to see here is that I've got a object model for my plant. It's going to follow ISA 95, which we definitely recommend that you start with. And we're going to be using both Sparkplug B and flat UNS. So I know that's a huge topic of conversation. Arlen has also done a ton of work to solve that as well. So we're going to have the benefits of both SPB and the benefits of flat and cloud. So unlocking massive value um, for both of those protocol standards. So yeah, I set up the cloud broker here. We set up a transmitter that essentially maps the tag tree structure that you have here. I also want to make note that these are UDT definitions. So these are ignition specific full power UDTs, and they're going to be transacting over both Sparkplug and over flat. And that's all going to be enabled with Arlen's Cirrus Link modules here. So it's probably,
Now, before
yeah,
you get
oh, go
into
ahead.
that, let's just
Yeah,
mention very, very quickly that a UDT basically lets you take. Look, if we were in 1980, we would have a Modicon, 200, and we would have just literally tags in a folder, right? All the tags, like a pipeline booster station, you may have your centrifugal pump along with all of your valves, everything all in just one folder. Now, as we've evolved, okay, well, now we've created where you can have multiple folders, but still, by the time you get that to a data lake, you basically, without structure like a UDT, you'll end up with a data swamp, not a data lake. So with UDTs, they basically let you take a machine or even a process and give it a name and give it structure to where, okay, at the top level, I've got my asset information for that model. I've got all of the measurements for that one machine. And like you have here, Jacob, you've got a UNS hierarchy going down to that. So by the time you go to that, I go, okay, the enterprise is Flexware, site area, unit device, and now we can manage that data going forward.
Yeah,
Yeah, and
and
I
I
think,
think
oh, go ahead.
sorry, I was just going to say, and I think that you'd get this recommendation from everyone on this call, so I hope I don't speak on everyone's behalf, but contextualizing and modeling that data at the source is where you're going to have the most knowledge about what is actually there and how do these units work and what's the precision of this instrument and what is the units I need to include along with this. So as Arlen said, when that data actually gets to someone who wants to use it for something, they have a catalog of all of the contextualization that they need to be able to use that information wherever it arrives at. And the great part about a publish and subscribe technology is when you publish it, you don't necessarily need to know who's going to subscribe, but you bundle up all of the information that they will need as a part of the building out of the model itself. And user-defined data types are just a fantastic way to organize all of that.
Yeah, absolutely. And of course, after the Prove It conference, all this buzz around, exporting SESME profiles, standardization, Arlen already doing all the work to standardize Sparkplug B and all the advantages that has when it comes to modeling. And it all comes back to, our original point is making that information human readable and accessible as you're moving it up through the stack all the way through cloud. So absolutely.
Yeah, and I think James made a really good hint on the problem and how people came up to this problem is, when IT folks got involved in our manufacturing world, right? They're like they had all these questions, but how do we answer all those questions? Like Arlen said that, number three, how is that better than number two? Nobody knows, right? So what James really easily hinted on was fix it at the source. And in our world, we are fixing it at the source by using Sparkplug B. So um, if Sparkplug B wasn't really available as like a protocol to push things in a contextualized way, it is so much harder to look at a table in a database and then figure out what is this data point trying to tell me, versus if we fix it at a source, like what we're doing here, you send everything that's relevant. Again, like Arlen said, we're not swamping anything, but we're putting things that are relevant according to the protocol, which is Sparkplug B. And I think Jacob and I will make sure we mention why sometimes non-Sparkplug B topics are important. But right now, I think what he's showing is Sparkplug B enabled information and why all the content is easy to get out. Go ahead, Jacob.
Yeah, and I'll show you, you can see the power of this right now. So as we're modeling this with Sparkplug B, the in-birth and debirth and that entire structure allows you to do extremely creative things at the subscriber level. So if I go to the engine here, every single thing that I publish into that tag tree automatically gets immediately pulled in as device information in real time. And I'm not having to coerce the subscriber to understand that object model because there's a standard object model, which is Sparkplug B. So that gets you enormous power and quick turn time where this entire setup here, of course, I'll show you, all this information is flowing over SPB here through the broker. It's encrypted here because that's protobuf as it's traveling in transit. Um, but that standardization of the model is kind of in essence how you go about simplifying UNS. How we've moved at this point in time in the industry to have such a solution that's so plug and play. So of course, so yeah, you can see here what that sort of power of standardization. So
Well,
yeah,
and that all that results in a single source of truth, right? That is the main advantage here is that, if we're scraping a database, if you're getting data off the back of the database, guess what? You got to hit another program to put it all back together again. So it's like Humpty Dumpty fell off the wall. We're going to send Humpty Dumpty to a data lake, and then we're going to write a bunch of Python code to put Humpty Dumpty back together again.
Absolutely, yeah. And I think going forward, there are these standard models now in protocol. I think even in the future, the next 5 years, we're going to have even more standardization around a data model. And Arlen at the Prove It show, showcased SESME integration and profile, very complete all the way through various protocols, OPC UA included, for standardization of object models. So I think it's very powerful. And we also have, we did all this Sparkplug B stuff, and now we're going to show you, you're going to get flat too. So Arlen just released a UNS component to the transmitter that is doing everything that you see on the right-hand side. So this is the object model moving through Sparkplug B and also moving through a very conventionally defined flat UNS hierarchy as suggested by Walker, all of that community, et cetera. So and I want to this would be the last thing I show, I think, is just how simple this is. So these are the only parameters that you need to specify to achieve this entire flat structure on the right side. So I will not lie at all. I think I spent 15-20 minutes getting this object model through Sparkplug B at a site broker and a cloud broker, through object model all the way through UDTs in about 15-20 minutes. And that's been largely possible because of the work Arlen's been doing with the Cirrus Link modules. But yeah, I think that's kind of where my demo ends a little bit. We could maybe circle back around with Eric, ask some questions, or
Hey,
Yeah.
Eric, before you do that, we did have a question that was submitted. If UNS is a concept, then can other machine-to-machine communication protocols be used as a transport mechanism to get that data from machines, equipment to UNS subscribers?
I'll maybe take this one because I haven't said it, but yeah, you can. What I think the industry has demonstrated is that MQTT is particularly well suited for this, but that's not saying you couldn't use other technologies for it. One of the benefits that I see with MQTT is interoperability with common vendors too, right? So if you look at, there's some different camps around different ways to collect and model data, but specifically MQTT and the extension of Sparkplug B as your kind of your layer of structure on top of it, it makes this much easier. And Jacob's example of kind of showing the flat MQTT structure, really where you're using that is when you're going to systems that are not designed to handle Sparkplug or looking for flat information. So for example, if we're going to talk to Kafka, we're usually sending data in a format that looks like that as opposed to Sparkplug, just because Kafka clients tend to be parsing all of that information when they receive it. Technology, there's lots of technologies out there, but I think, if you look at the industry and you look at the trends that at least that I've seen, is that MQTT is kind of been the clear leader because it's just a really good fit for the use case.
And the capabilities here, remember, MQTT in its original form was invented 25 years ago to solve a problem for Phillips 66 pipeline, right? They had space segment costs a lot of money, and we needed to save bandwidth. So by switching from poll response to MQTT, we were able to reduce their bandwidth usage by about 95%. And then after that, then you've got basically the ability to compress that. So we can send tens of thousands of measurements in a single Sparkplug message. So that is literally there for efficiency, getting data moved around. We've got cellular out in the world. We've got VSAT. We've got really crappy internet connections. And literally, we're trying to cater for that. But then when you get up to where now we're seeing the UNS transmitter. Now we can break it out into individual MQTT messages. But if I was at a plant with a million tags, which is unusual, you're not going to be able to publish a million tags with retain flags set into any, you'll take down any broker that's out there if you do that.
Yep.
Yep.
Absolutely. So, now we could maybe segue into your side, Eric. So, a lot of this might be somewhat abstract. You're seeing this data backplane. As a manufacturing engineer, where are the insights? Like, how am I translating this model into actionable outcomes? And we're going to go into a demo here. We've created somewhat more of a sophisticated object model here that is really going to lean into this idea of defined outcomes from object modeling and templating. And what we're going to see is, visualizations and screens and dashboarding and insights be materialized off of this object model in real time in a very automated fashion because it's been so templated. So yeah, that's what we're going to see in
Yeah.
a moment.
Can you see my screen? My screen should
Yep.
be sharing now, right? Yeah.
We
So
sure can, yeah.
So like Jacob said, I'm going to kind of keep this pretty brief, but I do want to give a brief example of kind of why this is useful, right? We've kind of talked about a lot of examples, but I also want to show why it's useful and why it's important to have a good data model. Because you can really empower other systems to see the data you're getting and automatically prove value out of that, right? So what I'm going to do here, Jacob is going to, through his portion of it, fire up a new site here. So Jacob, I don't know if you want to go ahead and fire that up whenever you're ready.
Yep.
And so you see here on this map, right, I can see a bunch of like different sites I have in my enterprise, right? They're all boiling some data up through some simulation we have. And so if we wait for him to run his though. So if you spin up a new site, right? So before, when you spin up a new site and you want to connect it to your enterprise, right? If you don't have the sort of UNS data model, then you have a lot of work you need to do to kind of go through actually configuring stuff on the enterprise, getting data going through. And this is also true to site level, right? You want to hook something new up, you're having to do a bunch of configuration. But if you saw there, right, like I had on here, because our data model is standardized in our UNS, I had these sites up here, but then when a new site turned on and started sending data through their broker, at the enterprise level, I didn't have to do anything, right? I just got a location that showed up, and I can click on that location, and I can see some different information about it, right? So I can get ideas of like all of this stuff that's coming through, and I can see data points that are coming from it, and each one has like the same types of data that are coming, right? So it's value that any other system, including this one, right? This isn't dealing with publishing the data, right? But it's receiving the data and you're improving value from it in a more from a user interface, right? The other things we can do with this is if I go into this one, I can also start driving some metrics that I want to show. So I can show an example of an OEE type dashboard here, where maybe we're gathering data from the machine level. Let me hop to maybe a smaller range here, right? Okay, so these machines are just starting up, so some of these data is probably going to be pretty low counts. But you can see here on the screen, right, that we're getting some counts going in. So because of the structure of the data and because of the context, like Arlen was talking about, where we can receive not just state codes, but we're able to receive contextual data about what those states mean, what do the counts mean, all of that kind of stuff. You can have systems like this that can read that data, and then you can start to have like drill downs of this. So you can have data, I have OEE coming from this line. I can see counts coming in automatically all across my enterprise here. And I can really start seeing that kind of information through here. Like I said, without any configuration you want to have. And adding a level onto that too, if you want to fire up another machine, so let's say now you go and you add a new machine to your system, right? So maybe you're not spinning up new facilities all the time. Jacob, let me know when you've started firing that one up, and then I'll refresh this.
Yep, it should be good.
Okay, so if I go back, and I should go to my line, and we might have to wait a second for the data to start coming in from it. I can see it. It looks like we haven't got data from it yet. we haven't got enough data yet for it to start showing up some OE values yet. But you can see here we got a machine 10 that came in, and automatically, again, no configuration I had to do, right? All just because all of our UNS structure is designed. I don't know why it's not coming up here, but that's fine. All because all of our UNS structure is defined well, we can see that we're starting to get actual values coming in, right? And we're automatically doing these kind of calculations. So this is just a simple example, right, of this. But as you can imagine, you can have lots of type of applications doing the same thing, and all pulling information from here to have automatic value be given to, um, different higher, like whoever's wanting to see this kind of data, right? All this data becomes available to all these different types of systems. So just wanted to give that kind of practical example to this, right, of how you can end up using this data before we continue on. So with that,
Yep. And I
going
just want to add one thing here, that the true power of UNS and Sparkplug and all the UDTs is actually what Eric just described, because the reason we were able to create a system that is ready to accept a new site, or it is ready to accept a new machine within a flip of a switch, basically, is what Jacob did, right? That was because we were expecting what to see when a site or a asset is added, right? So because of our pre-work that we did in getting ourselves set up properly, spinning up a site, spinning up an asset, spinning up a line has gotten so much faster. And as we demoed, within a few seconds, the data pipelines were set up properly. And I think going down a little bit into our discussion, I will talk about what the architecture looked like, and why it is rolling up this way. Go ahead.
I want to shout out too. It's like we didn't even discuss this. The infrastructure this is all running on is turnkey stood up by James 4IR. It's all managed. It came built basically for us. It's just as templated as everything that we showed thus far. So all of the infrastructure this is hosted on, at this point, we have solutions that even that is managed. Do you want to speak to your solution, James, or?
I always want to talk about infrastructure, so I really appreciate it whenever you bring it up. Yeah. So Factory Stack is our managed solution for delivering Ignition and the Ignition ecosystem. And in this case, if you noticed in the little URL at the top, it was spark.factorystack.io. And what's running up in the cloud is Ignition. There's a database, there's a load balancer, there's authentication services, there's security monitoring services. We're capturing log files. We have it basically all stood up and connected. And what's different about it versus kind of I'll say the traditional way of setting it up is we didn't go to the Azure portal or the AWS portal and click and choose our services. Everything we deploy is deployed as code. So when we deploy a factory stack, it uses the same code as every other factory stack, and we customize it based on the configuration that we need for that specific use case. So if we need one gateway or if we need 100 gateways, we can essentially configure the system to do that, apply the appropriate amount of resources and some configuration pieces to it, and then it's deployed and set up for the end user to use. So we also take advantage of a couple of different technologies as a part of this. We use what's called Kubernetes for the in-cloud workloads, which allows for us to dynamically scale and handle high availability in a little bit different way than is normally done on site. So what's cool about all this is not just that it's whiz-bang technology, but that it makes things easier for upgrades and updates and consistency for monitoring and management and support. And we can offer economies of scale because we're essentially using the same system for everyone, no matter what sort of configuration they're looking at, because we can modify and build it out based on what the user needs. So from a lot of folks will come to us for speed. Hey, I really want to get this done quickly, and it's something I'm either not comfortable with because I don't have experience in how to secure, how to manage these pieces in the cloud. The cloud's great for getting something working, but if you don't have the skill base and the experience for how to make sure that it's continuing to be secure and it's continuing to stay up to date and that it's continuing to function as it was originally deployed and intended, that's where people like us can come in and help with that. You know, ensuring proper security and working with the folks inside of the IT world to make sure that they're comfortable with how the architecture is handled, how data is stored, how remote access is provided. That's all kind of built into the way that we do things. So I could go on for the next 23 minutes, but I will stop unless there's other questions.
Yeah, as SIs, and I'm sure a lot of SIs out there will share similar sentiments, but you know, Arlen's work and your work, both of you, make our lives so much easier. So this demo, was easy, and UNS simplified in large part because of these various technologies that you've been able to make it so straightforward. So
I think the combination of the companies and Ignition and what's been deployed, it's not quite UNS in the box, but it's pretty close.
it's getting there. We're getting there.
Yep.
Once Sesame profiles start happening, it might be.
Great. So I do want to, walking through that, we kind of walked through an example. And while we were going through that, we kind of talked a lot about the configuration. So hopefully you guys have all seen some examples and some ideas of how you can take these concepts you're hearing and start to actually get data up into the UNS to start proving value, right, through like this one simple example. One thing we don't want to say, though, right, and we've talked about this a little bit too, right, is UNS is obviously a very broad topic. It's not a shrink wrap, like the way we do it is the right way to do it. It's what works best for your implementation. There's no out-of-the-box UNS sort of solution, right? So I do want to kind of talk about a little bit here, and I'd be interested in all of your guys' opinions here on just like some maybe tips, tricks, war stories that we're seeing as we help all these different customers with their UNS journeys to kind of help out, give some like practical advice for how we can get started on this. So I guess maybe the first thing I'd be interested in talking about is, there's a lot of places that we're getting data from, and all those pieces of data, all those different systems are probably scattered all about, maybe around the world, on different network levels and all that fun stuff, right? So I don't know, maybe can we talk about some best practices, tips, things to think about if you're just getting started and setting up like an infrastructure for how to make sure that you can get data from all these places? And I don't know, James, do you want to chat a little bit more about that one, maybe?
Yeah,
On top of
I mean, so if you look at kind of the corporate world and how applications in the corporate world have changed, at least in my career, and certainly it's been accelerating over the last few years. Things like email, messaging, and file storage, ERP, analytics, AI. Most companies, not all, but most, are using cloud for that. Whether it's public cloud, it's one versus the other. Sometimes they use some private cloud capabilities, but fundamentally they're looking to centralize that into a service that's not usually in a data center that they own, although there are some occasions where they do. So if your concept and this concept of the unified namespace needs to interact with information from there, you have to get your data to a place where it's available. So sometimes that means using tools to inject into cloud services that already exist. Sometimes that means having a presence in cloud or in a centralized data center with something like an enterprise broker and being able to basically follow the security principles and the rigor of the IT world, but provide the modeling and the value and the information from the OT world. And so yeah, it really is a deliberate design exercise between IT and OT. And OT folks, sometimes lack a little bit in terms of understanding how the cloud works and what services and how security works and why the IT people care about this. And IT people expect certain characteristics, data and transit and rest and being encrypted and zero trust and different sort of network architectures. And blending those worlds together, the tool set that you guys showed today, I haven't run into a place yet that hasn't been widely accepted by both sides of that coin.
And let's not forget when Chris and I started Cirrus Link 11 years ago. Hey, we knew a lot of customers, right? We've been doing protocol conversion and infrastructure for 30 years. So we went to all of our customers and we asked them, hey, have you seen this new thing called cloud? This was 10 years ago now. They said, over our dead body. We're going to keep our servers in the basement. We're going to hug them every morning. But you know what happened is that people started learning. Okay, now we understand it. Now we understand it is secure. But the problem is everybody jumped in about 5 or 6 years ago. And now they got in at the ground level and they started taking care of their EC2 containers and their, and their data lakes and all of that infrastructure. But now with things like what you do, James, with things like Snowflake, where now they're starting to abstract that to where you don't have to have 15 IT guys just taking care of the infrastructure just to get a piece of data into a Power BI dashboard.
Yep.
Yep. Jacob, if you want to share the architecture that we have for this demo again, and I'll piggyback off of the conversation that we're having. So and I'll also saw a question come in saying, UNS solves real-time data, but analytics needs trending. So how does UNS help there? That's a very fair question, but I don't think UNS stops at real time. UNS is helping drive the data for trending. And so yeah, perfect. So uh, before I get into the trending of data, let's just talk about this architecture a little bit. Um, when it comes to scaling, right? You do want to have proper infrastructure in place that helps you scale. So by scaling, I mean not just adding more machines, but also facilitating your production, right? So and if everybody here is strictly somebody who has worked on the floor or has been in the crossfire of the floor saying, why are we down, and why are we not getting our statuses and machines in dashboard? I need to know my quality now, right? So to facilitate production, you can't touch their systems. You are able to get data from them, but you're not allowed to interrupt them. So that's why in this demo we made sure that you see there's a full-blown site broker, right? The site broker is allowed to have data pushed out to our ignition in the cloud with 4IR's infrastructure, but the site broker is also there to help facilitate whatever the production requirements are. Data is not just needed on the top level. There are stages of data that people want at certain stages of production. So taking information away from the PLCs in a structured way with the UNS, with context, taking it to the site broker. If somebody needs it right then and there without adding more context, it's available, right? And then if you want to add more business context to it, well, it needs to go where the business data resides, right? So that's where we're taking the data from the site broker to our ignition instance where there are modules ready to accept it. But then now we have an enterprise level broker. This enterprise level broker can now not just facilitate your UNS based info, but it also has access to other systems. As just, an example, we have demoed AWS and Azure and Snowflake, whatever you have, right, in your org as an accepted system. But now tying, like, people talk about data science, data fabric, right? So to stitch your data fabric, manufacturing was always missing because nobody knew, and the example that I wrote in my answer to that question was, if a customer calls and says, why am I not getting my product on time? Why is my on-time delivery impacted? Well, customer service now has the power to not just go look at, did we have capacity when we took the order or not, but actually what happened when that order was produced. Did we have a lot of downtime? Yeah, sure. I can go check that machine out. I can go check that line out, right? Because manufacturing has enabled you to collect all that data. And to make more sense, I'm just going to say this, that people need data sets to drive a report. UNS basically helps automatically create that data set so that the reports are driven, right? So to the point where Power BI was involved, it needs a table with all the context, right? So when Arlen said Humpty Dumpty, yeah, Humpty Dumpty had a fall, but why it had a fall, you need the table to tell you why it had the fall. But that table is now created with the UNS going up the chain, and again, it is available every stage of the transition for whatever reason you need. So we're just basically, again, coming back to my previous point, we're facilitating to whoever needs the data in whatever way they need, but using the UNS.
Right. And I think using the more modern tools, a good example again is Snowflake. Remember with Sparkplug, if you're polling at 100 milliseconds and things are changing at 100 milliseconds, those are all going into basically a time series database in Snowflake or wherever you put it. So you can trend that as well as using it for all your real-time information.
Yeah, we have some customers that go straight into a Snowflake. We have some that use other ontology tools, and some that just put a time series database right in that infrastructure. So like timescale DB is one we commonly deploy, and you basically hook it up off the broker topic space, and you can log that information. The One of the issues with so many technology choices is there's so many technology choices. It's nice to have choices, but certainly there's very efficient ways to capture that time series data, whether it's in Snowflake or whether it's in your own time series database, so that you can have that historization of what is produced on the UNS broker.
So I want to continue on that thought actually. So if I was so let's say I'm starting out my UNS journey and I know I need to get this data somewhere, right? There's all these choices I'm getting bombarded with, right? What are some key points that we need to think that I should think about when I'm trying to decide, do I use Snowflake, do I use my own time series database, do I use an MS SQL database, right? What are things I should be thinking about in my head?
Your use case. figure out a problem to go solve and let the technology fit the problem. At least that's my advice usually. But yeah,
No, I agree. Yeah, you need to find a use case, because if the use case is to get data within a millisecond or a 1 second of event happening into somebody's hands, right? So then that answers your question, because okay, I'm trying to get an alert to somebody in their hand. So what do I need along the way, right? So use cases are where people start selecting their technologies, but sometimes IT also is always involved now, right? And this IT/OT, no longer a segregation now. Now they're becoming like siblings, but um, IT will come and say, well, I know you like Postgres because it's easy to use and it's Linux, but we are a MS SQL organization, so figure out a way to incorporate that. So there are other nuances that are involved, but like James said, use cases will you basically drive your technology selection.
Yeah,
I
I
think
couldn't agree more.
okay.
Yeah, as I said, I couldn't agree more. I mean, we see, maybe 5 years ago, Arlen started it way before Walker did. 2014, Walker got a Firebrand Award. Since then, we've had 10 years of POCs, hundreds of companies, manufacturers across the world, starting with this POC process, walking through UNS, and of course now we're just getting massive value. So proof is in the pudding. I think we're at a time where UNS is more approachable than ever. As a technologist, I have no skin in the game. I think UNS drives massive value, and that's why I think it's so important, because it really does help manufacturers. We're at a point where it's maybe it's not UNS in the box yet, but I highly encourage anyone watching this who has not started their UNS journey. Get started. It's more approachable than ever. You're going to see very quick turn time and be able to prove out value. And of course, like I said, it starts with your problems and what you're trying to solve, and solving those. So yeah.
I apologize for kind of jumping in twice here, but I was just going to add that the architecture that you guys put together for this, you could do a single machine use case or an entire enterprise use case without fundamentally changing that architecture. So it's a great architecture to use as a basis if there's a preference for a different database or configuration or transport. There's other things you can switch and change, but if you look at what's tried and true, there's a lot of companies that use exactly what you're using in this demonstration today to solve lots and lots of different types of problems.
And I'll just point out here that everything you've seen, everything you've heard us talk about, You can go after you get off this webinar. You can go to inductive automation. You can download Ignition. You can run it in trial mode, and you can do everything we're talking about today. That's the cool thing.
Yep.
Yep. Just 2 hours, keep resetting. Otherwise, you see some
Yep.
error and you will go down a rabbit hole and saying, why am I not succeeding? Oh.
Yeah. But you don't lose anything. I mean,
Yeah.
you can't believe the number of customers we have that, we'll get a large PO. We haven't talked to them. We've never heard of them. And we'll talk to them and say, where did you come from? Oh, we built the whole thing out in trial mode. Now we're ready to go to production.
It is an amazing way to get started, is to just inductive university, trial mode,
Absolutely.
just run at it, because it honestly is such a powerful tool set, and it allows for you to understand, and what was shown today is possible for a lot of different folks with a little bit of skill in this space to do. Now, to build out and to do it well, and to have kind of all of the I'll say the enterprise level parts of this, I think that's where partners come into play, and folks like Flexware can guide you through how to
Exactly.
build that for your enterprise.
Yep. But you can learn about it and then go to Flexware and say, hey, I saw this part, how do we scale this up? So every call I'm on, it's like, hey, where's an integrator can start helping me put all this together?
And I think the other cool thing too about this, right, with the freeness of it, is it makes you, with it such a low cost entry, well, being free to just try, right, is it really removes the barrier to just try it. I feel like a lot of times we see people that get kind of the paralysis by analysis, like, oh, we're going to sit there and we're not going to try it because we're going to just try to figure out every use case, every is this going to be good enough? Is this going to be good enough? And all the what ifs. And since it's free, you can really try it out. And if it doesn't work, then well, you just wasted a little bit of time, but at least you could test it out and try it. So you find out a lot as you go through it, as you go through the process of developing this. And a UNS is, I feel like you have a good structure for it, but it's also an evolving platform to a certain extent too, right? Because you're going to start out with one thing, start out with a smaller scale use case, and then it's going to grow as you add systems to it, and you're going to say, oh well, can I do that? Can I do this? And really build it into the system you want. So definitely helps with that. So I guess with that, look, what we have 5 minutes left here. So I think we've talked a lot about architecture, setting things up, getting data, how to functionally get data moving back and forth. I guess maybe if we could spend just a couple minutes left, the couple minutes we have left here, maybe talking about and giving some recommendations for. So getting data places is one part, right? And there's a challenge to that in itself, right? But the next part of that too is making sure the data you're getting there is meaningful, and so all your systems can understand it, and that. And we've talked a little bit about, hey, we need to add context to the data to change the integers to the like maybe JSON payload to strings, right? So I don't know, Jacob, do you maybe want to kick us off and talk a little bit about how you may get started in coming up with the data model, some advice you may have, and then
Yeah,
I'd also like to talk a little bit about how that may change depending on if you're doing real-time data, which is a lot of what we've been talking about, versus like maybe configuration data, stuff coming from like an ERP system, right?
hmm
And from machine systems, right? So.
yeah, sure. Um, yeah, I'll kind of start with data modeling and circle back around to an important concept in the space. But I think we've got all these examples, great examples: Sparkplug B, real-time data on-prem, amazing, for that object model in that use case. And then we also have ISA 95, Walker Reynolds flat UNS, and we've got definition namespace on that. We've got ad hoc blue red now. We've got telemetry, we've got functional namespace, very comprehensive data modeling templates and things that have been tried and proven out in the data model space. And of course, now we're getting SESME. We're having it seems like the industry is unifying on data models in an even larger scope and scale across, many different technologies. So I would say don't, you know, start with a template, start with people who've done the modeling before you and proven it out. There's so much good information online. Um, There's really good information in the community, in the Discord, etc. That's why I would start. And then that being said, this is the most important part. Don't let a data model paralyze you into not doing UNS. Data models aren't permanent. They change. They're going to change. They're already dynamic. The protocols and standards are changing, etc. Of course, standardization unlocks a whole bunch of power, but in my mind, the most powerful thing you're doing with UNS is eliminating digital thread. You're creating this common data backplane, for massive high throughput. So don't let the data model scare you. There's a lot of help out there, but don't let that be a
Yep.
reason why you don't get started.
You're here.
Great. Yeah. Yeah, I think that's a good point. It's a data model is a hard part. Not a hard part, right? It's all hard, but I mean, it's like there's so many things to consider. And I think the important thing too is before you can start talking, kind of like we talk about the architecture too, the data model follows a similar flow of like you don't really model the data without knowing your use cases, right? And so you kind of need to have a use case to go into it, not just saying like I'm going to build the one system that's going to solve all of the problems and not knowing what all the problems are.
I
So
might
like,
disagree with you a little bit there because, like, I
okay,
kind of feel like just building out your ISA 95 model makes a lot of sense for almost every single manufacturing facility. That said, there may be abstractions and additional modeling you want to do for specific use cases that are in addition to or on top of or at a next layer for that. And I think the concept that there's only one model, and I think Jacob said this, that's never going to fit the needs of the business. You're always going to need to do more and build more on top of that. And I think that's kind of, it's maybe a little lost in the conversations that we have, but there's always multiple levels of abstraction beyond the S95 model. But I think the S95 model is a really great descriptive way to talk about a facility and its manufacturing assets. So I think for me, I think that's where you start. But then obviously you then take your use cases and you have people that understand oh, this is where all of the synchronous motors are, and I want to do some vibration analysis on synchronous motors, and they can build an abstraction for that. Or again, there's lots of different things you can do, but I think getting started is a pretty consistent thing.
Yeah. I think this is for all the PLC guys out there. As soon as they make a UDT, you have started to do a data model.